All right, let's continue our look at casting and molding with a look at permanent mold techniques. These are molds that are going to be permanent, so we're not destroying them after each casting process. This is chapter 6 in your textbook. All right, and let's get things underway. So we saw this list before, right? So now we're going to focus on the right side of this, the permanent molds, and you can see there's a fair number of permanent mold casting methods that are shown here. We're going to look at a couple of these. We're going to look at die casting, slush casting, and centrifugal casting. Okay. So permanent mold techniques, the expendable mold, right? The what we looked at before, sand casting and whatnot, investment casting, that can be costly when large volumes are required. It can also take a lot of time. All right. So casting using reusable molds is much more economical. While you have higher upfront costs to get a very good mold created, typically out of steel or some other extremely hard metal, once you have that made, then you can use that over and over again. So that's going to spread out that high initial cost over many parts being made. The molds, however, are not truly permanent, right? Every casting operation is going to introduce mold wear and damage. And so they either need to be repaired or replaced. So they're not permanent in the sense that we can use them forever, but they're permanent in the sense that they're going to last for hundreds of cycles of casting. So the first method that we're going to look at is gravity die casting. And the gravity die casting, we're going to use reusable steel dies. That's what's going to be used for the molds. Notice that we're kind of changing terminology here. We're talking about dies instead of molds. So dies are kind of molds that are reusable, more or less permanent, right? Okay. The molten metal is fed into the dies using only gravity. So that's where the name comes from, gravity die casting. So we're using gravity to and dies to cast, right? So the pros for this method, we have short cycle times. It's relatively quick. We can have closer tolerances, again, because the dies are machined to a higher tolerance level, better surfaces. Thinner walls can be cast. Steel dies conduct heat very well. What that means is that once we pour the metal in, the heat is going to leave that area very quickly, which means that we're not going to get kind of the distorting effects that we have from contraction inside the die. And plus, we have shorter cycle times because the part is cooling faster, and so we can remove it faster, right? This typically can help to reduce or eliminate secondary machining operations. And we also have a finer microstructure, which leads to better material properties. Now, the cons of this are, again, as I said, we have a higher initial cost, right? It costs a lot of money, hundreds, if not thousands of dollars to create the high quality dies that we're going to be using here. Limited materials. Why do we have limited materials? Well, you cannot cast a metal that is going to have a higher melting temperature or be too abrasive for the steel dies. So that right there is going to limit you. Okay. You can't produce steel parts with steel dies because it would just destroy the dies. All right. Higher production volumes necessary for the process to be economical. So because of the high initial cost, we need to produce a large volume of parts so that we can spread that cost out amongst all those parts. And we have limited product size and weight, right? Typically, these are kind of smaller parts. All right, and there is a video of this. So again, I want to implore you, please check out the videos of this. This is a still from one of the videos of a gravity casting operation, a hand operation. So you get to see all the actions that this machinist, that this operator is doing here. So it's really informative. Now we also have low pressure die casting, right? So remember, gravity die casting, we're using gravity. So we're pouring the mold in from the top and we're using gravity to just fill it. we can also use low pressure die casting. Low pressure die casting is where we have the crucible material, right? The molten metal here. And we're using a low pressure to kind of draw the metal up into this shape, right? Dies are typically fed from below using gas pressure. Okay, so in this example right here, we're introducing the pressurized gas here, which is going to push down on the metal, and the metal is going to flow up here into the die to create the shape. Pressure is between 30 and 75 psi. So, it's about twice what you would see in a bicycle tire, right? Bicycle tire is around 30 psi, something like that. So maybe a little bit higher. So it's around a bicycle tire or twice a bicycle tire in terms of pressure. So we're not talking huge pressures here. Okay. Low pressure ensures laminar flow, right? So with the low pressure, we're going to get a nice flow. If we try to do it with high pressure, what's going to happen? This is going to shoot up here. We're going to get a lot of turbulence, a lot of oxidation, right? Finer details are possible. The pressure helps to overcome molten metal surface tension. So remember that the molten metal, regardless of whether it's aluminum or steel or iron or whatever it is, it's going to flow not like water, but more like honey or more like maple syrup. So with a low pressure die casting, that low pressure is going to help to push that thick fluid into all those nooks and crannies and crevices. Aluminum and magnesium are the most common metals used for low pressure die casting. High pressure die casting. Okay, now we're ramping it up, right? Pressure's up to 29,000 psi. Holy cow. So compare this to 30 to 75 psi, right? 29,000 psi is a whole world of difference, right? Material quality is typically poor because you're going to get turbulent flow here, right? When you're shooting a metal into a die at 29,000 psi or 20,000 psi or whatever, it is like a jet. So it's shooting in there. It's going to be very turbulent. You're going to get high oxidation. You're going to trap those oxides in there. And so you're going to get, the quality is going to be poor. This is used for high productivity, right? Automation, right? Robots. Thin-walled products, yes, you shoot it in there. It's going to penetrate those thin walls and go right into that cavity. Very short cycle times, good tolerance control, cold running eliminated. Cold running is what happens when you have metal that is solidifying before the other parts of it solidify and kind of create blockages, right? So because we're shooting this metal in at very high pressures, you're not going to get any cold running to happen. And it typically eliminates secondary machining because we can get very good tolerances and surface control. The cons of this, poor material quality, right? The turbulent flow is going to create a lot of problems, a lot of oxidation. It's only used for high production volume, which means we have to have an economy or an economic situation that suits high production volume. We have limited materials, right? So it can't be too viscous. It can't be too viscous. The metal cannot be too viscous or else you just can't shoot it in there. All right. So aluminum, zinc, magnesium, those are kind of the limited materials. Very high initial cost, right? We're talking machinery that is very specialized. And limited product size, around 44 pounds is what the estimate is for the product size and weight. All right. So here's a still taken again. I have some great videos of this, so you can really see this in action. And you can see this is a die for a high pressure casting operation, right? And these are the parts that are made. So typically high pressure casting, die casting is going to be used for parts that are not structural, right? They're not going to be in a machine or mechanism to provide structure or strength. They're going to be covers, right? So I think this is if I remember correctly, this part might be a housing cover for a motorcycle engine or a small outboard engine or some kind of small engine like that, which again is not structural. There's no weight bearing on that. It's just simply a cover, but it is intricate. You can see the intricate details here. And so that's why high pressure die casting is suited for this. So how does the high pressure die casting work? Well, we have our die here. So we have our two die halves, right? The die, the back side and the front side here. And this is the casting cavity. This is the shape that we want to create. So we pour the metal into this tube, and then we're going to have a piston that's going to ram it in there. And that's where you get your high pressure. It just, boom, rams it right in there, shoots it into this, kind of squirts it in. And then it cools and it opens up and you have your part. The last type of casting, permanent mold casting, that we're going to look at is centrifugal casting. Centrifugal casting is used, for example, to make pipes, steel pipes, metal pipes, iron pipes, okay? And so what you're going to do is you're going to take a roller, an object that, you know, that's going to be, that's going to have the shape on the inside of it, right? And this, you can see that we have sand lining here, and we're going to pour the metal into this, and then this is going to turn around, and that turning around is going to allow the metal, the molten metal, to coat the inside and keep it from filling in the outside. And the speed of it filling, or excuse me, the speed of it rotating is going to keep it on the outside by centrifugal force, right? Keep it on the outside as it cools. And so that's how we get these metal pipes. All right. Again, I have a great video for this. Vertical and horizontal centrifugal casting is done. I think I only did the horizontal one, but there is another one with centrifugal casting that you may find. I might have it on my YouTube channel. All right, people. So that is chapter 6. So in our last lecture series on this, chapter 7, we're going to look at plastic mold casting techniques. Okay. So I'll see you in the next video.